Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked math questions both at the high school slash university and college levels. Um, I'm currently a second year human biology student. And if anyone needs an additional schoolwork help or needs tutoring, you guys can check out the description box below. And other than that, we'll get started. So the first question for this session says how to find the vertex of a quadratic function. And if you guys recall that a quadratic function is basically a parabola. It has so the function is usually given as y is equal to ax squared plus bx plus c. So this is a normal quadratic function formula. However, if you want it in a vertex form, it's given by y, so vertex form. And to write it in the vertex form, you go y is equal to a, which is any coefficient, x minus h squared plus a. It could be plus or minus. However, where your h and k is the vertex of the parabola. So you can imagine that your h is basically your x and k is basically your y value for your vertex. And so there are some simple steps to follow to determine the vertex of the parabola or of any given parabola. And the first step is to express express the equation in the form we just mentioned, which is y equals to ax squared plus bx plus c, where a, b are coefficients and c is just a constant number. And then step 2 is to factor by completing the square. By completing the square. And so you basically have this equation, and you basically have to do to complete the square, where you're isolating all x and x squared, all x and x squared terms in the right side. Of the equation. Okay, so that's for step 2. Step 3 is you have to simplify and convert the right side to a squared expression. So you basically convert into a squared expression. And what I mean by that is you would have, like, for example, our vertex form, it's in a squared. We would have something like x minus h squared, something like that, right? You would have it in a squared form. And so like where y is equal to a, so your fourth step would be to isolate the y term. So you move the so you can so you isolate the y term, right? And you can find the vertex form basically. So you isolate y and then you can, or isolate x, um, and then you can find out the answer. So isolate y term. Okay, so to further explain this, we can use an example. So let's say example where it says to find the vertex of the equation y equals 6x squared plus 12x minus 10. Okay, so step one is to express it as step one says to express it as um a a template, or like how a normal quadratic function is placed. So in this case, it is in that term, it is in that layout. And so step two would be completing the square. So you would isolate all the x's onto one side. And so number two, so you would you would keep everything, so all the x terms on one side and the others on the other side. So in this case, we would have to just move the minus 10 to the other side. And you would just have y plus 10 is equal to 6x squared plus 12x. So you have your x terms in one side. And so then we need a leading coefficient of 1 for completing the square. So we have to factor out the current leading coefficient of 6 in this term. So what we can do, we can say that y plus 10 is equal to 6x plus 2, right? So um so in this case, if you take a note that we have an additional variable here, which is y, so we can't just get rid of it. So the factored 6, we can add a box to both sides. So the box will be multiplied by so we would have, so basically what we would have basically, what I mean by this is that we would have like a blank spot here. And so um and so here, I'll just write it on the line. So since we're dealing with y, another variable, we have two variables in this case, we can put like an imaginary box here. And so it will become plus 6 times 6 times something, we don't know, and 6, then we have squared plus 2x and something on that side as well. So this is what we have. Then to complete the missing term, we would take half of the coefficient of the x term inside the parenthesis, inside the bracket, square it, and place it in the underline. So half of the coefficient of x term, which is right here, would be, so you just write half of the coefficient of the x term And so in this case, it's 2x. So you do 2 divided by 2, 1. So, and then you have to square it. Square it. So you have 1 squared, which is just 1. So therefore, our missing term is 1. So hence you can say, let's say that y plus 10 plus 6 times 1 is equal to 6 into x squared plus 2x plus 1. Okay. In this case, it's plus 1 since our value here is positive, so we just say it's plus 1. Okay. And then to further simplify this, we have here y plus 10 plus 6 is equal to 6 x squared plus 2x plus 1. And then further simplify, plus 16 is equal to, we can just, then we have 6x squared plus 2x 1. Okay, so this was all step 2. Now step 3 would be to convert it into a squared expression. And to do that, we would just have to square this whole term. And as you guys could see, this is a perfect square. And so we would have y plus 16 is equal to 6x plus squared. Okay. And then step 4, we would have to isolate the y term. So we would have to move the plus 16 to the other side of the equal sign. Okay. So if you move it to the other side, it's going to become a negative. So we have y is equal to 6x plus 1 squared minus. Okay. So this was step 4. And now to find the vertex. So as you can probably guys see, this is in vertex form. So this is in vertex form. If you guys, so like I would, so this is in the layout of y is equal to ax minus h squared plus k, right? Where your h and k is the vertex. So then therefore the vertex of the quadratic function is, so since it's x plus 1, we would have x plus 1, right? You don't deal with the square here. X plus 1 is equal to 0, so then therefore x is equal to -1, and you have y is equal to -6. So our vertex would be -1, negative. So this is your vertex. And so this is how you find a vertex, and this is the way to solve these type of questions. Okay, and so we just did this one. Is Okay, so next question here says, how do you know if an equation is linear or nonlinear? Okay, so to determine if an equation is linear or nonlinear, we first have to look at the equation, and a linear equation can be expressed. So linear linear equation would be expressed as y is equal to mx plus b, right? Our slope equation, our normal regular slope equation, where m is the slope of the line and b is the y-intercept, right? So slope, this is your slope, this is your y-intercept, right? And so, if the exponent of the variable is greater than 1, the graph of the equation will not be a line. So if you have basically, so for example, for nonlinear, would be something like y is equal to ax squared plus bx plus a. So this is where your exponent, so exponent on x is greater than 1. So for example, if you want to graph, a linear equation, for example, let's say, graph y equals 2x 1, right? And so your y-intercept, this is your y-intercept, right? And so if we want to draw this, just arbitrarily this, if you have graph here, it would look something like, so your y-intercept is +1, so it's going to be somewhere right here. It's going to cross this point right here, and since it's positive, it will go from up, go down from up. Okay, so let's say this y is your x, this is y equals 2x, which we have got over here. Okay. And so the next one, if you want to graph x squared plus 1, so this is a nonlinear, linear. As you can see, the line is just a straight diagonal line, just one straight line. And if you say graph, y equals x squared plus 1. So this is a parabola. Right? And this is not going to be a linear. This is not linear. This is not going to be a straight line. It will be something like this. So this is still our y-intercept, +1. So let me just say that this over here is +1. Okay, and it would go something. Like this. Y. Yeah. So it would go something like this. It would open upwards since it's positive, and this is, so since it has a degree of 2, coefficient of 2, you know that it's a parabola and it's gonna go, it would have basically 2 ways. It would open up like this, as you guys can see, like this. And so therefore, to determine the equation is linear or nonlinear, we can look at the equation and see it is expressed in a form if it is expressed in the form of y equals mx plus b, and if the exponent of the variable is greater than 1, then the graph is nonlinear. Okay? So this is third question says, how do you find a polynomial of degree 3 that has zeros, -3, 0, and 1? Okay, so if you got, so we have to first recall that that the zeros of a polynomial are factors of, or the roots of the polynomial, which would equal to 0. It would make the whole equation equal to 0. So it's in a form, so it is in a form of, so those zeros, they're in a form of x minus a, so where x is your variable and minus a is any number, where a is a non-zero number. Okay, and so this is where your whole equation will equal to 0. With that, we can write the factors as products of each other. So since when you're dealing with a polynomial equation, they have more than one term, and so you would basically have like x minus a, x minus a. You can also have x minus a, another coefficient. This could equal to 0 depending on which degree you have. That's how many products or zeros you would have. So in this case, we're talking about third degree, so we would have three zeros. Okay, and so since we are given the zeros of the polynomial, we have to basically work backwards to find the polynomial, the whole expression. So let polynomial function equals f of x. Okay, so let's say we have f of x is equal, so we're given the zeros, which is x. So since it's -3, it would be +3, as that's your actual 0. The next one would be x minus 0. The next would be x, right? So since this is x minus 0, we can just say x plus 3. First, so we can just say this is x plus 3, and x minus, right? These are our 3 zeros. So now we just have to further expand this. We're just working backwards. We're just going to FOIL this out. So I would first do these two, and then whatever I get, I would multiply that with the x. And so I would just say squared plus 3x minus x minus 3, right? So you have x squared, x minus 3x. So then you just have to further simplify this. Squared plus 2x minus 3. So this is all multiplied by x. So then you just have to multiply it with the x now. So x cubed plus 2x squared minus 3x. So this is what I get. This is how you would get the answer. And therefore, this is the polynomial of degree 3 that has the zeros of -3, 0, and 1. Next question says, what is the algebraic expression for the quotient of a number and 8? Okay, so when we're talking about this type of questions, we're trying to come up with an expression or an equation that represents um, the question, what they're asking for. Um, so since we're given some information about it, that it is a quotient of a number and 8, so we can express this problem as a number divided by 8. So when you're talking about quotient, quotient is means divide. Okay, you just think divide. So that this means, so let's say let um let's say that we can write what is the of a number. So let's say let number equal n. Okay, and so we can basically say that since it's saying that the quotient of a number, so means the number divided by a number, and that is 8. So we can say that therefore um, the quotient of a number quotient of a number and 8 is expressed by n over 8. Okay, and this is what they so is says evaluate the expression 7 log base 7 of 49. Okay, so to do this question, this is a log question, and so what we're trying to find out is what does log base 7 of 49 equal to? Okay, and so this, if you go back to our basic formula of a log, any log function, it's basically y equals to log base a of x, where if and only if your x, right, where you can say x is equal to a to the power of y. So we have to apply the above property over here. So for this specific question, we can say that a is equal to 7 and our x is equal to 49, right? And we need to find y. So y is equal, so this is what we're trying to find. So we can say that log, we can rewrite it, say log base so we can say log of 7y is equal to log of 49. Okay, so we're just saying that log of a to the power of y is equal to log of x. So then we can also say that log of 7y is equal to log of 7 to the power of 2. So then what you have here, we can ln both sides basically, which is a natural logarithm, and say we can, so let's say ln both sides. And we have, so we have ln of 7y to ln 7 over 2. And so then you can have, so then this becomes y 1 7 is equal to 2 1 7. Okay, and so what you can do, so basically you can say you can now solve for y, and you have 2 1 7 over 1 7, so then 1 7 1 7 gets cancelled, and you have 5 equals. Okay, so then you can say therefore log a 7 of 49 is equal to this curve. So our next question here says explain when to use long division before applying log rules. So to when you need to basically apply long log rules is when we have to basically integrate. So in order, and what I mean by that is uh, is before we integrate a rational expression, right? This is when we're doing long division, we're using rational expressions. We need to check first if it can be decomposed into a smaller if it could be simplified even more. Then that way it would be easier to integrate the whole expression. And to do that, to simplify the expression, we use long division. So for example, in this case, let's say we have an expression. So for example, we have x squared plus 1 all over x. And if we apply long division, the result would be, right, if you just divide x with this whole number, you would just have x plus 1 over x. So long division, right? And this is what you would have, x plus 1 over x. And this way the expression is easy to evaluate when we need to integrate. So to integrate this, so to integrate, we have to take the derivative of both sides, and so we have to take the derivative of this whole expression here, which is x squared plus 1 over x. And so this is basically equal to the derivative of x. So after doing long division, plus, keep in mind the plus here, plus the derivative of 1 over x, or integrating you're integrating 1 over x. And so the rest is already the concept of integration, and this is when you would want to use long division. Okay, and yeah, so basically okay. Question: what are the solutions to the quadratic equation x squared? So x squared is equal to 7x plus 4. Okay, so we're trying to find out the roots or the zeros of this equation, or what x is equal to. And in order to do that, we have to first put this in the right order or in the right equation. And what I mean by that is that we have to this equation has to be in the form of y is equal to x, or really y, let's say, supposed to be in a squared plus bx plus c is equal to 0. It's supposed to be in this term. And so what we can do is move everything to this side. And so therefore we can have x squared minus 7x minus 4. So I just change, since you're moving to the other side of the equal sign, it will change its signs. And then this is equal to 0. So now, since now we have to first see if we have two numbers that when you multiply them, it would give you 4. And if you add them, it would give you negative 7. So the only two numbers really are 2 and 2 and 4 and 1. So none of them would give you, if you add them up, it won't give you negative 7. So in this case, use the quadratic form. Okay, so this is where you have x is equal to minus b plus minus b squared minus 4ac all over 2a. Okay, and so in this case, a, this is our a, these are a, b, and c. So a in this case is 1, b is negative 7, and c is negative 4. So we would have negative 7 as b plus minus negative 7 squared minus 4. A is 1, b is negative 4, all over 2 times. So if we further simplify this, we have 7 plus minus 49 minus or plus, and then you have all over 2. Now we just have to further compute this. We have 7 plus or minus 65 all over 2. And so from this, we can say that the answer in this case, so x, so since we would have two roots in this case, x1 would be 7 plus root 65 over 2, and x2 would be 7 minus 65 over 2. Okay, so these are our two zeros, and this is a solution of the given quadratic function. And so yeah. Our next question says, what values of x is in the solution set of 9? Okay, so we have to do this. So this is an inequality question. So it's saying to determine the values of x. So this inequality, so we have 9 2x plus 1. X minus 18. Okay, and so to determine this, the solution would be to first perform the distributive property of multiplication over addition. and if any, to simplify. So what we have to do here first is basically multiply out 9 on the left hand side, and first let's do that. So we have 9 times 2x. We'll just write it 9 2x 1. Okay. We just have to distribute this. So we have 18x plus 9 is greater than 9x 18. And so now we have to divide each side by 9 since we're trying to get we have to first move the 18, or put the like terms into one side and the others in the other side. So I would basically move the 18 to this side, and so the 18 to this side and the 9 to the other side. So all the like terms are together basically. So you have your 18x minus 9x, and you have minus 9. So over here you would have 9x. You would have 9x, and this would be negative 27. So then what you would have here is you would have to divide each side by 9. And so you have x is greater less than negative 3, but we don't want it to be a negative, so in order to make it a positive, we have to change the side, so it's going to be 3. And so therefore we can say therefore the value of x value of in the given solution x is x greater than 3, or you can say x is into the domain of positive. This will be infinity. So x could be in any range between these. This is ready. Okay, so next question we have here says, what is the equivalent logarithmic equation to the following expression, which is log base 3 of 81 equal to 4. Okay, so the equivalent expression and solution would be in this case, so we can basically rewrite this as, y is equal to log base a of x, where x is equal to a to the power of, right? And so in this case, x would be 3 to the power of 4. And so we can rewrite this by saying y is equal or yeah, y is equal, or is it now right? Log base 3 of 81 is equal to log base 3. I'm just changing 81 and substituting x, which is equal to 3 to the power 4, and this is basically saying, so since the base and x, basically the number of x is the same, so that becomes, it gets cancelled out. You basically have 4, so this is basically equal to 4. Okay, since I'll just write this, since base x is same is equal to 1. So this is, you can say 4 is 4 times 1, and this is equal to 4. So this is one way to, so this is the equivalent logarithmic function. Okay, so our next question says, write x squared minus 8x plus 13. So we have to write this, okay, x squared minus 8x plus 13 is equal to 0 in the form of x minus a squared is equal to b, where a and b are integers. Okay, so to do this, the following steps is into transforming the quadratic in the form of x minus a squared equals equal to b. So what we can do here is, the first step would be to subtract both sides of the equation by c, since we're just trying to eliminate c in this case. So we have a ax squared plus bx, basically. Okay, so first step would be to subtract c. So if we do that, we have x squared plus 8x on both sides, so plus 13 minus 13 equal to 1. Okay, and for 0 minus 13. Okay, and so you can see that this gets cancelled out. So we have x squared plus 8x equal to minus 13. And so the next step would be to perform the completing the square. So as you can see, x minus a squared equals to b. This is kind of like a vertex form, or completing the square. Perfect squares. Okay, so now what we have to do for the second step is completing the square. And in order to do that, if you guys recall, we take the middle term and divide it by 2 and then square it. So then middle term is 8, negative 8. So what we have to do, we have to divide it by 2 and square it. So we have here, we have a negative 4 squared, which is 16. And so now we have to add this to the both sides of the equation, our original equation. So we have x squared minus 8x plus 16 is equal to negative 13 plus 16. Okay, so then we have, so we just, with the like terms, we just simplify this even more. 8x plus 16 is equal to 3. So then step 3, finally, factor the left-hand side of the equation since it is a perfect square trinomial. So what we have to do, we can complete the square by saying that this basically looks like, and you can put this into a complete square. So this is equal to minus 4 squared, and this is equal to, right? So as you can see, this is in the form of x minus a squared equal to b, right? And so this is your answer. Okay, so our next question says how do you solve 1 x plus 1 is equal to 1? Okay, so we have basically have 1, we have 1 x plus 1 is equal to, okay, so how do we solve for this? So the natural logarithm, so 1 is a natural logarithm logarithmic function with base e. Base e. And so we can use the following property of the logarithmic functions. So basically you can say that e to the power of 1 of x is equal to x, since this gets cancelled out. It's basically the inverse. And so then transforming the given expression, so you're transforming the given expression. So what you're doing here, you're just putting, so I'll just write 1x plus 1 is equal to 1. And so we are just transforming, we're just trying to write this like this, okay? And so what we're trying to do, we're just going to put e1, and so this is x plus 1. Instead of x, we're putting the value of x over here is x plus 1 is equal to e to the power of 1. Okay, so any number raised to 1 is equal to that number, right? So e to the power of 1 is basically just e. So as you know, if it's e to the power of ln of something, e to the power of ln is, that's going to get cancelled out because they're the inverse. So we basically have x plus 1 is equal to e. Okay, and so we can further solve for x. We just have to move 1 to the other side, so e minus 1. So then therefore x is equal to e. Okay. I also forgot to mention, so this is basically saying that this is log base of e is equal to 1. Okay, so and 1 is inverse of, okay, so that's how it gets cancelled out with each other. So this is the solution for this question. So this is, and so that was the end of our session. If you guys like this Q&A, please subscribe to this channel, share and comment on this video. And if anyone has any personal questions or needs one-on-one tutoring services, check out the description box below. Follow the links and ask your personal questions. Other than that, I'm Shanjida, and I'll hope to see you guys soon. Bye bye.